Well, some of them, the granite in the Great Pyramid comes from more than 500 miles to the south. If you look at the famous King's Chamber, its walls and its roof are, the ceiling of the King's Chamber are all made with gigantic granite blocks.
For hundreds of years, people have wondered how the ancient Egyptians cut huge granite blocks, some weighing many tons, using tools that seemed too weak. Graham Hancock, a writer who always questions history, spent decades looking into this mystery. His work, using science, experiments, and careful study, shows surprising evidence. The Egyptians may have had techniques much more advanced than we thought. Could the secrets of how they made these amazing stones finally be revealed? Join us in this video as we reveal the details. Graham Hancock explains how ancient Egyptians cut granite. For many thousands of years, the ancient stone monuments of Egypt have stood quietly in the desert, holding their secrets in silence. Travelers, historians, and scientists have all looked at these structures with a sense of wonder. Among the most famous of these monuments is the Great Pyramid of Giza, a massive structure that has fascinated people for centuries. Inside this pyramid is a chamber often called the King's Chamber. The walls and the ceiling of this room are built from enormous granite blocks. These stones are not small pieces that could be moved easily. Each block weighs many tons, and some are believed to weigh close to 70 tons. Granite is one of the hardest stones that people commonly work with. It is strong, dense, and extremely difficult to shape. Because of this, the question of how ancient workers cut and shaped these stones has become one of the biggest mysteries surrounding ancient Egypt. The commonly accepted explanation from traditional archaeology is that ancient Egyptians used copper tools, stone pounders, and sand as an abrasive material to slowly shape the granite. According to this view, workers would strike the stone again and again, or rub it with abrasive sand until it gradually took the desired shape. However, some observers have pointed out that copper is a very soft metal when compared with granite. On the Mohs hardness scale, copper ranks around 3, while granite falls between 6 and 7. This difference means that copper tools would wear down very quickly when used against granite. Because of this, critics have questioned whether copper chisels alone could realistically shape such enormous blocks of stone with the level of precision that appears in Egyptian monuments. Another part of the puzzle comes from discoveries made in the 19th century by Flinders Petrie, one of the early pioneers of scientific archaeology in Egypt. Petrie was different from many explorers of his time because he focused on careful measurement. Instead of searching only for treasure or statues, he used measuring instruments to study how ancient objects were made. During his work, Petrie discovered cylindrical pieces of granite that had been left behind during ancient drilling operations. These pieces are often called drill cores. At first glance, they appear to be simple waste material from stoneworking. But when Petrie studied them closely, he noticed spiral grooves running around the surface of the cores. The grooves looked similar to the threads on a screw. After studying the grooves carefully, Petrie concluded that the drilling tool had moved through the granite in a steady spiral motion. According to his measurements, the tool appeared to advance into the stone by roughly 1/10 of an inch with each rotation. If that interpretation is correct, the drilling process would have been surprisingly efficient for such a hard material. Petrie also considered how much force might have been required to produce such results. Based on his calculations, the downward pressure needed to cut granite at that rate may have been very large. Some estimates suggested that the pressure could have reached several tons. This raised further questions about how ancient workers might have generated such force using simple tools. The drill cores that Petrie studied are still preserved today in the museum collections of University College London. Many visitors walk past them without paying much attention. They appear small and simple compared with the Great Pyramids and statues of Egypt. Yet to some researchers, these small pieces of stone hold important clues about the methods that ancient builders may have used. In several cases, the measurements show that the shapes are extremely consistent from one side to the other. This level of precision has led some researchers to wonder whether ancient stoneworkers used techniques that are still not fully understood today. For this reason, the stone artifacts of Egypt continue to attract attention from historians, engineers, and scientists. The granite blocks of the pyramids, the massive boxes in the underground tunnels, the spiral grooves in ancient drill cores, and the delicate stone vessels all contribute to an ongoing effort to understand how these remarkable objects were created thousands of years ago. So, were the Egyptians using tools and skills we still do not fully understand? And when engineers began studying these monuments more closely, what did they discover? Let's find out. Engineers, new questions, and the debate over lost technology. As interest in ancient Egyptian stonework continued to grow, a number of engineers began to study the monuments with fresh eyes. Unlike archaeologists, who often focus on cultural history and ancient texts, engineers tend to examine how objects were physically produced. They study surfaces, measurements, angles, and manufacturing marks to understand the processes behind construction. One of the most widely discussed figures in this field is Christopher Dunn. Dunn spent many decades working in aerospace manufacturing. His career involved producing components that had to meet extremely strict tolerances. In industries such as aviation, even tiny measurement errors can cause serious problems, so engineers become very skilled at recognizing precise surfaces and accurate machining. When Dunn began visiting Egypt, he applied this experience to the monuments he encountered. Over the course of many trips, he examined structures such as the granite boxes in the underground chambers of Saqqara. Using measuring tools and straight edges, he evaluated how flat the surfaces were and how accurately the corners aligned. Dunn reported that some of the surfaces inside these granite boxes appeared remarkably precise. According to his observations, the walls seemed very flat, and the corners appeared sharply squared. From his perspective as an engineer, this level of accuracy suggested careful planning and advanced shaping techniques. Other engineers who studied Egyptian monuments noticed similar features. They observed long, straight lines cut into granite blocks that resembled saw marks. Some drill holes appeared to have smooth walls and very consistent diameters. In certain statues and carvings, the left and right sides of the face seemed almost perfectly symmetrical. These observations led some engineers to suggest that ancient builders might have used tools or techniques more advanced than those normally described in traditional archaeological explanations. The debate then expanded into a larger discussion about the possible origins of such knowledge. One of the individuals who became closely associated with this discussion is Graham Hancock. Hancock has argued that certain ancient structures around the world may contain evidence of a much older civilization that existed long before the rise of well-known historical societies. According to this idea, an advanced culture may have flourished during the distant past. Supporters of this theory sometimes suggest that this civilization existed near the end of the last ice age. Around 12,000 years ago, major environmental changes occurred as glaciers melted and sea levels rose dramatically. Some researchers believe that these changes may have caused widespread flooding in coastal regions where early human settlements could have existed. In this interpretation, much of the knowledge developed by that ancient civilization might have been lost during these dramatic events. However, small groups of survivors may have carried fragments of their knowledge to other parts of the world. These survivors could have shared their understanding with later societies, including the early cultures of Egypt. Within this framework, the precise stonework found in ancient Egypt might represent knowledge that was inherited rather than invented by the dynastic Egyptians themselves. Proponents of this theory point out that the Great Pyramid of Giza appears to be the most precisely constructed pyramid in Egypt. Later pyramids often appear less stable and less carefully built. To some observers, this pattern seems unusual if Egyptian builders were gradually improving their skills over time. However, the idea of a lost advanced civilization remains highly controversial. Most archaeologists strongly reject it. The mainstream explanation continues to emphasize the ingenuity and persistence of ancient Egyptian workers. Archaeologists point to evidence showing that Egyptians used stone pounders made of dolerite, as well as copper tools and abrasive sand, to gradually shape stone surfaces. Despite these explanations, certain discoveries have kept the discussion alive. In 1993, a German engineer named Rudolf Gantenbrink carried out a robotic exploration inside the Great Pyramid. He designed a small robot that could travel through narrow shafts that were too small for people to enter. As the robot moved upward through one of these passages, it eventually reached a small stone door fitted with copper handles. The discovery created excitement because no one knew what might lie behind the door. Later, investigations drilled a small hole through it and revealed another sealed barrier beyond. The purpose of the hidden space remained uncertain. Another important development occurred in 2017, when scientists used a technique known as muon tomography to scan the interior of the Great Pyramid. This method detects cosmic particles that pass through solid structures and allows researchers to map hidden spaces. The results revealed a large empty area above the Grand Gallery. The findings were published in the scientific journal Nature. The discovery showed that the pyramid contains a previously unknown void. The exact purpose of this space is still unclear, and researchers continue to study the structure in hopes of learning more about its design. Because of discoveries like these, the monuments of Egypt continue to inspire curiosity and debate. Some researchers believe the evidence points toward technologies or knowledge that have not yet been fully explained. Others argue that patient experimentation and human creativity are enough to account for the achievements of ancient builders. What remains certain is that the stone monuments themselves still stand today. As technology improves and new methods of analysis become available, researchers may continue uncovering new clues about how these remarkable works of stone were created. Could a hidden ingredient in their tools be the key to their unbelievable precision? Keep watching for more. A new clue hidden inside ancient granite. For a very long time, people who study ancient Egypt have tried to understand one difficult question. That question is simple to ask, but very hard to answer. How did the ancient Egyptians cut and shape granite so precisely thousands of years ago? Granite is not an easy stone to work with. It is extremely strong and very resistant to cutting. Even today, when modern workers have powerful machines and diamond cutting tools, shaping granite is still slow and demanding work. The stone contains minerals like quartz, feldspar, and mica, which make it tough and durable. Because of this, granite is often used in modern buildings, monuments, and countertops, where strength and durability are important. In ancient Egypt, granite appeared in some of the most important structures ever built. One famous example is the king's chamber located inside the Great Pyramid of Giza. Inside that chamber, the walls and ceiling are made from massive blocks of granite. These stones are not small pieces that could be easily moved. Some of them weigh more than 70 tons. Moving stones of that size would have required enormous effort, but shaping them with precision was an even greater challenge. Another well-known structure where granite was used is the Valley Temple of Khafra. In this temple, huge granite blocks were carefully cut and placed together. When people look closely at the joints between these stones, they often notice how tightly the pieces fit. The surfaces appear smooth, and the joints seem extremely narrow. In some places, the stones appear to meet so closely that it is difficult to imagine how they were shaped with simple tools. For many years, the commonly accepted explanation was that ancient Egyptian workers used copper tools together with sand to slowly grind and cut granite surfaces. Copper was one of the metals available during that time, and sand could act as an abrasive material. According to this idea, workers would push copper saws or drills against the stone, while sand helped grind the granite little by little. However, granite is much harder than copper. On the Mohs hardness scale, copper ranks around 3, while granite ranges between 6 and 7. This difference means that copper tools would wear down quickly when used directly against granite. Because of this, some researchers began to question whether copper tools and sand alone could really explain the smooth surfaces and precise shapes seen in ancient monuments. One of the people who studied these questions closely was Christopher Dunn, a manufacturing engineer who spent many years working with precision machining. Dunn had experience producing mechanical components that required extremely accurate measurements. When he examined ancient Egyptian stonework, he noticed something that caught his attention. Some surfaces appeared remarkably flat. Certain drilled holes also appeared extremely circular and consistent. From Dunn's perspective, these features looked similar to the results produced by modern industrial equipment. He described the stone surfaces as being accurate to extremely small measurements. Observations like these raised new questions about how ancient builders achieved such results. Researchers also noticed unusual patterns on cylindrical pieces of granite known as drill cores. These cores are pieces of stone left behind after drilling operations. On the surface of some of these cores, spiral grooves can be seen wrapping around the stone. The grooves suggest that the drilling tool moved into the granite while rotating in a steady motion. These spiral marks puzzled many investigators because they seemed difficult to explain using simple tools alone. Some engineers believed the marks suggested a controlled cutting process rather than random grinding. Because of these unanswered questions, further scientific analysis was eventually carried out. Could the use of corundum reveal even more hidden techniques the ancients mastered? Let's take a closer look. The hidden science behind ancient Egyptian granite cutting. A collaboration developed between Graham Hancock and materials scientist Masoud Garb, who specializes in the study of friction and wear between surfaces. Dr. Garb used highly advanced instruments to examine the ancient granite surfaces. One of the tools used in the study was a scanning electron microscope. This machine allows scientists to see details that are far too small to be visible with ordinary microscopes. The instrument can magnify surfaces many thousands of times and reveal tiny particles trapped inside scratches and grooves. When Dr. Garb examined the cutting marks on ancient granite samples, he expected to find traces of sand or copper. These materials would have supported the traditional explanation of how the stone was cut. However, the results turned out to be different from what he expected. Inside the grooves, the microscope revealed tiny particles of a mineral known as corundum. Corundum is extremely hard. If ancient workers had used corundum as part of their cutting process, it would help explain how copper tools could work effectively on granite. Instead of the copper itself cutting the stone, the hard corundum particles could have done most of the actual grinding. Another interesting detail is that significant deposits of corundum are not known to exist within Egypt itself. This means that if ancient craftsmen used corundum intentionally, they may have obtained it through trade with distant regions. Ancient Egypt had trade connections with many neighboring lands, so it is possible that valuable minerals were transported over long distances. This microscopic discovery introduced a new idea into the discussion about ancient Egyptian technology. It suggested that ancient craftsmen may have understood the usefulness of very hard minerals and used them to improve their stoneworking methods. While the full details of these techniques are still being studied, the discovery opened the door to a new way of thinking about how granite might have been shaped thousands of years ago. If the ancients mastered cutting granite with such precision, then what other hidden techniques or knowledge might they have used in building the pyramids and monuments we still marvel at today? Let's find out. Testing the corundum theory. After the discovery of corundum particles in ancient granite grooves, researchers wanted to know if this mineral could truly explain how the Egyptians cut such hard stone. Finding a mineral inside a scratch is one thing, but proving how it worked requires careful testing. Because of this, a series of experiments were organized to see whether copper tools combined with different abrasive materials could reproduce the same types of cuts seen in ancient artifacts. These tests involved granite blocks, copper cutting tools, and several kinds of abrasive powders. The purpose of the experiments was simple. Researchers wanted to compare how well different materials worked when used with copper tools. They tested sand, quartz powder, and a mixture containing corundum particles. The first tests used ordinary sand, which had long been suggested as the main abrasive used by ancient Egyptian workers. In these experiments, copper tools were pressed against granite, while sand was added between the tool and the stone. The results were slow. The copper tools wore down quickly, and the cutting process moved forward only a tiny amount at a time. In some cases, the progress was measured in fractions of a millimeter per hour. The surfaces produced by this method were also rough and uneven. This made it difficult to match the smooth finishes seen in many ancient artifacts. Next, researchers tried quartz powder as the abrasive material. Quartz is harder than copper, so it provided slightly better results. The cutting speed increased somewhat, but the improvement was still small. The granite was still very difficult to shape, and the results did not fully resemble the precision seen in ancient monuments. The most dramatic results appeared when the experiments used a mixture that included corundum particles. Corundum is extremely hard, and when it was mixed into a slurry with water and applied between the copper tool and the granite surface, the cutting process changed noticeably. Instead of struggling against the stone, the copper tool began guiding the abrasive particles across the granite surface. The hard corundum grains did most of the grinding while the copper tool simply held them in place. This allowed the stone to be cut more smoothly and more efficiently. The cutting speed increased several times, compared with the sand experiments. The surfaces produced were also much smoother and more consistent. Observers noticed that the copper tools lasted much longer before wearing down. Perhaps the most interesting result occurred during drilling experiments. When corundum slurry was used with rotating copper tools, the drilling process produced cylindrical cores with spiral grooves. These grooves looked very similar to the spiral marks found on ancient drill cores discovered at Egyptian archaeological sites. This result suggested that the ancient marks might indeed have been produced by a similar abrasive cutting process. The experiments demonstrated that copper tools, when combined with a sufficiently hard abrasive, could create the types of cuts seen in ancient granite artifacts. However, the experiments also showed that the process required skill. The mixture had to be carefully balanced. If the slurry became too thin, it lost its cutting power. If it became too thick, the abrasive particles would clog the cutting groove. Maintaining the correct mixture required attention and experience. This detail suggests that ancient craftsmen may have developed specialized knowledge about how to prepare and use abrasive mixtures. Such knowledge could have been passed down through generations of skilled workers who learned the techniques through training and practice. The findings were presented to groups of scientists and engineers who study materials and manufacturing processes. Some specialists responded positively, noting that microscopic traces of abrasives embedded in stone surfaces might represent the only surviving evidence of ancient cutting techniques. At the same time, discussion about the interpretation of these results continues. Some archaeologists believe more research is needed to confirm how widely such methods were used. Others are interested in studying whether trade networks existed that could have supplied corundum to Egypt during the periods when major monuments were built. Even with these ongoing debates, the experiments have provided an important new perspective on ancient Egyptian craftsmanship. They show that combining copper tools with extremely hard abrasives could allow workers to cut granite more efficiently than previously believed. If ancient craftsmen truly used minerals like corundum to shape granite, it would suggest a deeper understanding of materials and tools than many people once imagined. Instead of relying only on simple tools and brute force, they may have carefully studied how different minerals behaved and used that knowledge to improve their techniques. The stone monuments of Egypt still stand today, silent but powerful reminders of the skill and knowledge of the people who built them thousands of years ago. As modern researchers continue to study these structures with new technology, each discovery brings us a little closer to understanding how these remarkable achievements were made. If ancient Egypt holds secrets few dare to question, what other mysteries has Graham Hancock risked everything to investigate, following clues that most scholars refuse to touch? Let's learn more. Graham Hancock, the tireless seeker of hidden truths. Graham Hancock has spent decades exploring the mysteries of ancient civilizations. He is not a typical historian, he is not an Egyptologist, he is not part of the academic elite. Instead, Hancock comes from a background in journalism, which gave him a different kind of freedom. He learned to ask questions that others would not. He learned to look beyond accepted stories and search for the evidence that might have been overlooked. Throughout his career, Hancock has challenged the conventional understanding of history, often putting himself at odds with mainstream scholars. His approach is to gather facts, travel to the sites, speak with experts in many fields, and follow the clues wherever they lead. One of Hancock's most significant areas of research has been the Great Pyramid of Giza. The official story says that Pharaoh Khufu built the pyramid around 2500 BC. According to traditional accounts, 20,000 workers used copper tools and simple sleds to move millions of limestone blocks. The story goes that this massive project took only 20 years to complete. However, Hancock noticed something that did not fit. The interior of the pyramid is almost entirely blank. Unlike other royal tombs, there are no inscriptions, no hieroglyphs, no religious texts, and no clear signs of ownership. The king's chamber has a plain granite sarcophagus, empty and undecorated. Hancock questioned the evidence linking Khufu to the pyramid. The only supposed proof is a quarry mark discovered in the 19th century. However, that claim is weak, with no witnesses and inconsistencies in the records. Hancock suggested that the pyramid might not have been built by Khufu at all. Perhaps it was inherited or repurposed by later Egyptian rulers. This idea challenges the foundation of mainstream Egyptology, but provides a fresh perspective on an enduring mystery. Beyond the question of who built the pyramid, Hancock focuses on how it was built. The precision of the construction is astonishing. The pyramid is aligned almost perfectly to true north. Its base is level across 13 acres, and the stones fit together with incredible accuracy. Some granite blocks weigh more than 70 tons, yet they are placed with such precision that a razor blade cannot fit between them. Hancock points out that the tools described in official accounts, copper chisels and dolerite hammers, could not have achieved this. Even today, with modern technology, replicating this feat would be extremely difficult. Hancock interprets these facts as evidence of advanced knowledge. He emphasizes that the builders understood engineering, geometry, and astronomy far beyond what is assumed for that era. For Hancock, the Great Pyramid is more than a tomb. It is a testament to human ingenuity. His work demonstrates a rare combination of curiosity, patience, and persistence. Hancock does not settle for easy answers. He examines every detail, questions every assumption, and searches for evidence that has been ignored. He is a modern investigator of ancient mysteries, a seeker of truths hidden in stone, and a challenger of historical orthodoxy. If Graham Hancock has already uncovered clues that challenge everything we thought we knew about the pyramids, what other ancient technologies and lost knowledge might he reveal next? Let's delve deeper. Decoding the Sphinx and the Lost Civilization Hypothesis. Following his studies of the Great Pyramid, Hancock turned his attention to the Great Sphinx of Giza. Unlike the pyramids, the Sphinx presents a different kind of puzzle. It is carved from a single mass of limestone and has weathered over millennia. Conventional scholars date it to around 2500 BCE, suggesting it was built during Khufu's reign. However, Hancock noticed evidence that challenges this timeline. The erosion patterns on the Sphinx indicate the effects of prolonged rainfall, something Egypt has not experienced for thousands of years. This type of weathering points to a much earlier construction date, possibly as far back as 10,500 BCE. Hancock examined the Sphinx alongside the pyramids and noticed something remarkable: alignment with the stars. He connected the layout of the Giza Plateau to the constellation of Orion. The three main pyramids mirror the three stars of Orion's belt, and this alignment would have matched the night sky around 10,500 BCE. Hancock combines geological evidence with astronomical data to suggest that the pyramids and the Sphinx were designed with a deep understanding of celestial patterns. This leads Hancock to propose a radical idea. The true builders of the Giza monuments were not the known pharaohs, but survivors of a lost civilization. According to Hancock, this civilization possessed advanced knowledge of architecture, astronomy, and engineering. Their society may have been destroyed by a global cataclysm around 12,800 years ago, leaving only fragments of their knowledge behind. Hancock calls these individuals the magicians of the gods, skilled people whose expertise was passed down and later influenced known ancient cultures. Hancock also looks at global patterns, noting similarities in pyramids and sacred sites across continents. From Teotihuacan in Mexico to Angkor Wat in Cambodia, structures share comparable dimensions, celestial alignments, and architectural techniques. Hancock interprets these as signs of a shared knowledge or influence originating from this lost civilization. He emphasizes that the evidence is not merely speculative. It comes from measurable data, careful observation, and cross-disciplinary analysis. Through his research, Hancock illustrates the importance of questioning accepted history. He shows that what we are taught in schools may only tell part of the story. By combining fieldwork, scientific study, and historical analysis, Hancock demonstrates that ancient civilizations may have been far more advanced than previously believed. He presents a compelling case that the pyramids and the Sphinx are not isolated monuments, but part of a broader, sophisticated tradition. In all of his investigations, Hancock stands out as a relentless seeker. He is persistent, skeptical, and committed to uncovering evidence wherever it leads. His work challenges assumptions, encourages fresh inquiry, and provides new ways to understand the mysteries of our past. By examining ancient structures, erosion patterns, celestial alignments, and global parallels, Hancock continues to redefine our perception of human history. He is, without question, one of the most determined and thoughtful explorers of ancient mysteries in modern times. How do you think the ancient Egyptians cut granite? Share your thoughts in the comments section below. Thank you for joining us as we uncovered the hidden secrets of how the ancient Egyptians cut granite. Don't forget to like and subscribe. Click the next video on your screen to explore more mysteries of ancient history. See you there.